Apparently, I end the video abruptly. I didn't realize. So yeah, let's continue to question two, tutorial question one. So the purpose itself is to promote group articulation technique between formulas and setting initial conditions. So you remember this thing we're talking about summary of dealing of all these things. We have to know necessary parameters. This is the portion that is trying to strengthen our understanding on this portion. So therefore, yeah, let's start. So we have a question. This is a tutorial question two. I mean question tutorial two question one. So trace of the free body is determined by this equation. So when you measure, then you derive an equation, and then you plot it out. You have this spring movement. So your purpose is to actually find the friction force, the stiffness, the natural frequency, and the period of the system. Okay, you are given this graph, and then you're asked to find. And therefore, the body itself has a mass, 50 kg, and released with a zero velocity. So this is a question to ask you to solve for these things. So typically, maybe one department wants you to design this type of damping system or this type of spring. So they pass it to you and ask you to to have this thing solved for its friction force, stiffness, and initial frequency for the system in order to create a spring. So they actually derive a graph and then they want you to do this. So this graph is derived from a program, maybe some software, and then says that okay, this thing is suitable, this graph is suitable for certain design. So therefore, you as an engineer, you have to solve for this. So therefore, let's start off with setting up what we have. For this case, we are not using this anymore because we really understand the movement, because you already know that the graph itself is a damping system. Okay, and then now we can also draw FBD because we have no graph, we have nothing at all. One key thing is that we are dealing with the parameters itself. So give me a minute, I'll just do. Okay, so this is the question that I've pasted here. So the first thing you need to do is actually to identify all the parameters and the so maybe I can write it down. Yeah, give me a minute. So you have to first identify all given parameters for whatever that is assigned in this question, and then secondly we have to produce whatever general formula you have, like let's say omega, the natural frequency formula, and then we just derive the amplitude decay formula. So these are the things that we're gonna derive. So the first thing first is we know that this is 50 kg. Okay, this is identify all given parameters. The first one we identify that is 50 kg, and then second thing is that we know it's zero velocity. The third one is the amplitude or displacement of the mass, and then what are the stuff, and then also the period. So you have to find the period itself, but nonetheless we know that there is a second, the time. And then the next thing is to produce a general formula. So we have maybe I pause the video along. So this is the parameter, the formulas, and then from here you can actually see the natural frequency. So we have natural frequency, we have friction force. We don't know what is friction force. We don't know what is stiffness matrix, but we know what is mass. We know what is mass over here, and then we know this 2 pi, but I'm missing certain things. We don't know k, and therefore we know that there is a certain trend saying that we need to solve for this first. So therefore, what is the period? So this is a slightly tedious way. I mean, you have to first also identify your cycle, the number of cycles within this period. Okay, so within this period we have one cycle. Okay, until here, one cycle, and then until here is two cycles, and there is three cycles. So what I mean is, this is one cycle, this is two cycle, then this is three cycle, and we have going down, and then you expect you will come out. So this is half cycle. Defining cycles for calculation of t. Okay, so therefore the t is equals to the number of cycles over the time. Okay, so okay, hold on a while. Okay, it's time over number of cycles. Sorry, so it's time over number of cycles, and that as you know, time mean period itself is one cycle, right? And therefore we have to solve for the time for one cycle, okay, in order to get a period. So therefore the time itself is 1.4 seconds for the whole span of this 1.4 seconds, and the time itself is 1.4 seconds, and so we have number of cycles over here, so you divide. It's just a simple math, you just divide. And therefore we have 1.4 divided by 3.5, we will have 0.4 seconds for the period itself. So for this we can actually solve for our natural frequency, and therefore yeah. Okay, so this is the thing, 2 pi over period. We take this formula, we know our period already, and you calculate simple math. But however, do take note, although simple math, I always do divided by 0.4. I forget the pi, I always forget the pi. So you have to 2 times pi divided by 0.4 in order to get this. This is a very, very serious careless mistake. Okay, you have to really take into account. Okay, please. Okay, if you have this wrong, everything will go wrong. Okay, this is really one of the most serious matter. And then once we solve for omega, you will know that the natural frequency can also take into this form. Okay, k over m square root. And therefore, since you know your natural frequency, you know your mass. Your mass is 50 kg, and therefore you can find your k. So okay, so yeah, then we derived our natural frequency equals to 15.7 radian per second. As we know, natural frequency is 15.7 radian per second is equals to k over 50 kg. So we solve for k, we bring this over, is 15.7 squared times 50. We bring it over, equals to this value for k. And then for SI unit wise, just for you to, it's a good, idea. Just that this one is dimensionless. So apparently what it means is that when you bring this square root over here, it's square. So this will become radian square per second square. So times kg equals to kg per second square. Okay, so kg per second square itself, it's actually Newton, which is actually not Newton, I mean Newton per meter. So what it means is that, so kg per second square is Newton per meter, because kg meter per second square is actually Newton. Okay, this is Newton. So times 1 over meter, so Newton per meter. As you can see, we have no meter over here, because radian itself is dimensionless, so it's like that. So if you don't mean, I believe you understand what I mean. So this one times this one is equal to kg over s square, and this is Newton per meter. Okay, so if you were to times a meter inside, you'll get Newton. Okay, so Newton itself is kg meter per second square ma. So in order to write this into this form, you have to change, in this manner. This is just a concept. And then once we get our k, our natural frequency, what are the things that we are needed to find? We have our stiffness, we have our natural frequency, we have our period. We don't know what is our friction force. So let's calculate our friction force. So give me a minute. In order to solve for F, we use this formula, the last one, 4F over K. Okay, so the F itself is the force, the friction force. Okay, so the friction force actually, if intuitionally, it will cause decay across one cycle. Okay, and therefore, we're using this concept that we have learned earlier from lesson 2. We know that the amplitude decrease to by 50 millimeter. So at first, this is across 3.5 cycles, if you remember. So at first it's 52 millimeter, and then now it's 2 millimeter. So therefore, across this 3.5 cycle, we have 50 millimeter amplitude loss. Okay. So therefore, you can deduce that now we know that one cycle is equals to 4f over k, and that 3.5 cycles is equals to 4f over k times 3.5. Yeah, it's just math. Is equals to the difference in amplitude over 3.5 cycles. So this one is the difference between amplitude between two cycles. Between one cycle. Okay, so this is one cycle and this is 3.5 cycle. So the difference itself is, as I mentioned, is 52 minus 2, which is 50. Okay, it's the amplitude loss between here. Okay, maybe I should define it. Give me a minute. So this is the 50 millimeter, and so with this concept, we can actually set this thing, okay, this portion over here into here. So this is step 8. So step 8 wise, you sub in whatever things your parameters are. So you have 4f over your k. Okay, your k is over here, and then you multiply by 3.5, which is 3.5 cycles, equals to 0.05 meter. Because now it's millimeter, you have to change the meter. So you have to be very careful, because just now I didn't calculate properly. So from here you can actually see there's two careless mistakes that I've made. The first one is the dimensions you have to change. The second one is if you have to include 2 pi. If you remember just now I say when I divide I didn't include the pi itself. So these are the two things you need to be very, very careful of it. And then once you do up the math, you will get 44.016 Newton. So this is meter so this is Newton, and then this is Newton per meter. So apparently when you do everything up, because Newton per meter, you multiply by meter, you get Newton. And this is the 3.5 is just a dimensionless cycle. So therefore we already end this tutorial. But I want to make known one of the things is that the zero velocity is not being said much. It's because it's just a description. So at first we thought that is the initial condition, but however it is in this case only okay, it turned out to be a parameter. So what does this mean is that zero velocity means that when before you release the mass itself, right, if you remember long time ago, when you release when you pull it out and before you release, there is no velocity after you release it start to boom and then got velocity already. So this is the essential meaning of that. And another thing is that two careless mistakes. Okay, the radian, please remember to include the radian. Okay, the radian, the pi, sorry, the pi. You have to include the pi when you solve for this. And then another one is to make sure your units, okay, change the proper unit, okay, change the meter and everything. So with this I end this part, okay, is to familiarize your understanding for the lesson 2 and lesson 1. And then for the next set of the video is about a new topic, which is free vibration with viscous friction. And I'll see you in the next day.